Now we look at separation of variables, which is one of the most widely used techniques for solving partial differential equations. So from the midterm, the idea is to look for a solution where the unknown function splits into functions of the individual variables alone. So in other words, it looks like a product of a function of x alone, so there's no t's inside this expression, times a function of t alone, so there's no x's inside this expression. Okay, and so is it justified to expect that there is a solution of this form? Well, no, but this is a differential equation solving course, right? So even if a guess is unfounded and unjustified, if it produces an answer that can be verified to be correct, then hey, we win. So don't worry too much about it. It might be sort of an immoral method of going about mathematics, but in a Machiavellian way, it gets the job done. So what happens is when we make this substitution into the PDE, then it's going to split the PDE into ODEs for each variable. And so what we find is that we end up with a boundary value problem for y, and notice that x is the spatial variable, and it's going to give us an initial value problem, or for g, and notice that t is the temporal variable. So we'll get two problems, and then we can solve these through whatever means necessary. So for example, for working with the spatial variable, we might use Fourier transform, Fourier series, because those are well adapted to dealing with boundary conditions. We might, for the temporal one, use Laplace or some more elementary technique, so depending on the occasion. So then the boundary value problem that we get is actually going to be a type of eigenvalue problem. And it's the full general form of this eigenvalue problem is called a Sturm-Liouville. It looks a lot like Louisville, but it's not. It's Liouville. And this one will provide a way to find solutions. And there'll be solutions for given in terms of eigenvalues. So there'll be some sequence of eigenvalues, typically infinitely many, and there'll be the corresponding parts for them. So they'll in general look like some constant, and then there'll be the spatial part, and then there'll be the temporal part. And so then by superposition, the general form of the solution will be some infinite series of all of these guys. And then what we will do is, by evaluating at some initial time, Then we will have our initial condition, and at the same time we will have Cn times Yn times Gn of 0. And so this looks like some some series of these functions y's. And so we'll use this to compute a Fourier series, or we'll use Fourier series techniques then to figure out what those Cn's are, or those alpha n's.